A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Imagine if every time you wanted to turn on a light in your house, you had to log into a different dashboard for the bulb, a separate one for the switch, and a third one to check if you could afford the electricity that minute. That is exactly where we are with AI infrastructure in early 26. We have these brilliant models and powerful tools, but they're all living in different zip codes.
It is the fragmentation of the action era. We spent the last few years obsessed with the brain, the LLM. But now that we're actually asking the brain to use hands, the tools and MCP servers, we've realized the nervous system is just a bunch of duct tape and prayer. By the way, today's episode is powered by Google Gemini 3 Flash, which is fitting because we're talking about the very plumbing that makes models like Gemini actually useful in a corporate environment. Today's prompt from Daniel is about the unified AI infrastructure layer. He's looking for that single pane of glass that handles LLM routing, MCP namespacing, observability, and cost tracking all in one go. I'm Herman Poppleberry, and I've been digging into whether this God mode for AI dev actually exists yet.
It's a classic evolution, right? We start with a wild west of APIs, then we get gateways, which are basically just fancy proxies, and now we're hitting the wall where a proxy isn't enough. Daniel's point is sharp calling something, an AI gateway. Today usually just means it's a middleman for your tokens. But if I'm building a production agent, I don't just care about tokens. I care about the Jira tool it just called, the database it queried, and whether the junior dev who ran the prompt just spent $400 of the department budget on a recursive loop.
You hit on the three pillars there: inference, action, and governance. Right now, most teams are using light LLM or OpenRouter for the inference piece. They might be using a separate MCP aggregator for their tools. And then they've got a third dashboard, maybe something like Langfuse or Arise for observability. The problem is that these systems don't talk to each other. If your LLM gateway routes a request to Claude because GPT-4 is lagging, your observability tool sees the switch, but does your tool server registry know that Claude might need a different prompting style for that specific MCP tool? Usually the answer is no, and the whole thing becomes a debugging nightmare.
It feels like we're missing a name for this. If it's not just a gateway, what is it? Is it a control plane? An AI operating system?
The industry is actually coalescing around the term AI control plane. Think of it like a service mesh, but specifically for the non-deterministic nature of AI. There's also this more technical phrase being tossed around by companies like Tetrate called single origin AI infrastructure. The idea is that your application code should only ever talk to one URL, one endpoint. You send a request to api.company.ai, and that single layer handles the model selection, attaches the right MCP tools based on your permissions, tracks the cost, and logs the entire trace.
That sounds like a dream for a DevOps lead, but a nightmare to build. Let's deconstruct the fragmentation for a second, because I think people underestimate how messy this is. If I'm a developer today, I have to manage my OpenAI keys, my Anthropic keys, my local MCP server addresses, and my environment variables for 5 different tools. If I want to swap a model, I'm not just changing a string in a config file, I'm potentially breaking the way my tools are called.
And that's just the functional side. Think about the security implications. If you have an MCP server that has access to your internal customer database, how are you gating that? Right now, most people are just hard-coding those permissions into the agent system prompt. You are a helpful assistant, please don't delete the database. That is not security, that's a polite request. A true AI control plane would have a policy engine. It would say Korn is logged in, he has read only access to the database. So when the LLM tries to call the delete record tool via the MCP server, the control plane intercepts it and says access denied before it even reaches the tool.
It's funny you mention that because we've seen this movie before with traditional APIs. We went from just call the server to use an API gateway like Kong or Apigee to handle OAuth and rate limiting. It feels like we're trying to reinvent Apigee, but for a world where the API call is actually a natural language request that might trigger 3 other API calls.
The difference is the state and the context. A traditional API gateway is mostly stateless. It checks your token, looks at the route, and passes you through. An AI control plane has to be context aware. It has to understand the intent. If the intent requires a high reasoning model, the gateway should be smart enough to say, I'm routing this to O1 or Claude 3.5 Sonnet because the user is asking for architectural analysis.
Okay, so let's get into what's actually out there. Does this mythical single pane of glass exist, or is Daniel just dreaming of a better world?
We're getting very close. There are a few players moving into this control plane space that are actually trying to bridge the gap between LLMs and MCP. One that stands out is Graph-Based Nexus. They've basically built exactly what Daniel is describing. It's an enterprise-grade layer where you plug in your models and your MCP servers, and it gives you a single GraphQL or REST endpoint. But the killer feature there is MCP namespacing.
Explain namespacing to me like I'm a sloth who's only had 1 cup of coffee. Why does it matter?
Okay, imagine you have 2 MCP servers, one for your Slack and one for your internal documentation. Both of them might have a tool called search. If you just dump them both into an agent, the agent gets confused. Which search do I use? Namespacing allows the control plane to organize them as tslack.searchta and docs.searchta. It prevents tool name collisions. But more importantly, it allows the gateway to decide which tools to expose to the model based on the specific request. You don't want to overwhelm a smaller, cheaper model with 100 tools it doesn't need. The control plane acts as a filter.
So it's like a specialized waiter who only brings the tools to the table that you actually ordered. I like that. But what about the observability piece? Because that's usually where the duct tape starts peeling off.
This is where it gets technical. Most gateways give you token in, token out data. But if the LLM calls an MCP tool to check the weather, and the weather API is down, a standard gateway just sees a failed request from the model. A true unified infrastructure layer uses something like the Open Inference standard. This is a protocol that allows the trace to follow the request to every hop. It sees user asked a question. Gateway chose Claude. Claude called the weather MCP called the actual API, the API returned a 404 error. You get a single unified trace of the whole thought process and action process.
That's a huge deal for cost tracking too, right? Because tokens are only half the story. If a tool call triggers a heavy database query that costs me $5 in compute, I need that billed to the same AI transaction as the 3 cents of GPT-4o tokens.
Precisely. Well, I shouldn't say precisely, you know I'm not supposed to. But yes, that is the core of cost per action tracking. If you're a fintech company and you're running a fleet of agents, you need to know the total cost of ownership for a specific task. If you're just tracking tokens, you're missing the iceberg under the water. Companies like Tyke are also moving into this. They've launched Tyke AI Studio, which is trying to treat AI as a first-class citizen in the API management world. They're looking at it from the perspective of governance and policy. How do we apply the same security standards we use for our banking APIs to our LLM prompts?
It sounds like we're moving from AI as a toy to AI as infrastructure. But there's a catch, isn't there? There's always a catch. If I put all my eggs in one control plane basket, aren't I just creating a massive single point of failure? If my unified AI layer goes down, my entire company's intelligence goes dark.
That is the big trade-off. It's the complexity concentration problem. By unifying everything, you create a very high value target for both outages and security breaches. If someone hacks your AI control plane, they don't just get your API keys, they get access to every tool, every database connection, and every bit of telemetry in your system. It's why we're seeing a big push for zero trust in this space. NetFoundry recently open-sourced some projects specifically for securing MCP and LLM resources. They want to make sure that even if the gateway is there, the actual connection between the gateway and the MCP server is encrypted and authenticated at a network level.
I'm also thinking about the vendor lock-in aspect. If I spend 6 months setting up my policies, tool namespaces, and routing logic in one specific control plane provider, how hard is it to leave? It feels like we're trading LLM lock-in for infrastructure lock-in.
It's a valid concern. However, because these tools are starting to use open standards like MCP and open inference, it's not as bad as it used to be. The logic lives in the gateway, but the components, the models, and the tool servers are still portable. It's much easier to move from one MCP-compliant gateway to another than it is to rewrite a codebase that has hard-coded OpenAI calls everywhere.
Let's talk about the market reality check. Daniel asked if we're still duct taping 3 or 4 tools together. From what you're seeing, is the average dev team actually using these unified layers yet? Or are they still in the light LLM plus LangFuse plus custom Python script phase?
Most are still duct taping. The tools I mentioned, Graph-Based Nexus, Tetrate, Tyche, are the early adopters and enterprise solutions. If you're a solo dev or a small startup, you're probably still running a local MCP server and calling it directly from a cursor or a custom script. But the production gap is real. Once you try to scale an agent to 10,000 users, the duct tape starts to snap. You realize you can't manage 10 different MCP host addresses across a distributed team. You need a registry. You need a central point of truth.
It's the day 2 problem. Day 1 is, look, the agent can book a flight. Day 2 is, why did the agent book 10 flights for the same person and cost us $5,000 in cancellation fees? And who authorized it to access the credit card tool in the first place?
And that's why this unified layer is inevitable. We've seen this with every other wave of tech. We had the cloud, then we needed cloud management platforms. We had containers, then we needed Kubernetes. We have AI agents, and now we need the AI control plane. What's interesting to me is the contextual routing piece. Imagine a world where the gateway doesn't just route based on cost or speed, but based on tool proficiency.
Oh, that's a cool thought. Like, Model A is better at using the SQL tool, but Model B is better at the creative writing tool.
Yes. Imagine your control plane has an evaluations loop built in. It tracks which models produce the most successful outcomes for specific MCP tools. Over time, the gateway becomes smarter than the models it's routing to. It becomes the brain that decides which subbrain is best for the task at hand. That's a level of optimization you just can't get if your tool registry and your model router are in separate silos.
It also helps with the model drift problem. If OpenAI updates GPT-4o and suddenly it's worse at formatting JSON for your specific database tool, a unified layer catches that in the observability data and can automatically fail over to Claude or a fine-tuned Llama model without a human ever having to look at a dashboard.
This is where we get into the self-healing infrastructure territory. If the unified layer sees that a specific MCP server is timing out, it can spin up a backup instance or route those requests to a different tool that provides similar data. We're talking about a level of resilience that most AI apps today simply don't have. Most AI apps today are brittle. One API hiccup and the whole agentic chain falls apart.
So, let's look at the architecture of a true unified layer. If Daniel were to sit down and sketch this out on a whiteboard, what are the core components?
It starts with the ingress layer. This is your single API endpoint that accepts prompts. Behind that, you have the policy engine. This is the bouncer. It checks the user's identity and says, are you allowed to use the financial advisor's agent? And are you allowed to use the withdraw funds tool? If that passes, it goes to the contextual router. This piece looks at the prompt and decides which LLM to use and which subset of your MCP catalog to attach to the request.
And the MCP catalog is dynamic, right? It's not just a static list.
It has to be dynamic. It should be able to discover new MCP servers as they come online. Then the request is sent to the LLM. But here's the crucial part. The tool execution happens through the gateway, not from the model directly. The model says, I want to call the search tool. The gateway sees that, executes the search on the model's behalf, sanitizes the result, making sure no sensitive data is leaking back to the provider, and then hands the data back to the model.
That sanitization step is huge for the pro-privacy crowd. You could have a data loss prevention layer right in the middle of your AI stack.
It's essential for any regulated industry. If an LLM accidentally tries to send a social security number from a database tool back to a third-party model provider, the unified layer can redact it in real time. Finally, you have the telemetry pipeline, which takes the traces from the LLM and the tool calls and pipes them into your observability and billing systems. It's a complete loop.
It sounds like a lot of moving parts. What's the biggest technical hurdle to making this the standard way we build AI? Is it latency?
Latency is always the concern when you add a middleman. Every layer of policy checking and redaction adds milliseconds. But in the world of LLMs, where a response might take 3 seconds anyway, adding 50 milliseconds for security and routing is a trade-off. Most enterprises will take any day. The real hurdle is standardization. MCP is a great start, but we need more agreement on how intent and policy are described.
We're basically waiting for the SQL of AI infrastructure, a common language that everyone agrees on.
We might be closer than we think. The open inference standard is gaining a lot of steam, and with the big tech players like Google and Anthropic getting behind things like MCP, the pieces are falling into place. It's also worth noting how this changes the developer experience. Right now, building an AI agent feels like being a pioneer. You're building your own roads, digging your own wells. With a unified control plane, it starts to feel like building a modern web app. You plug into the infrastructure and focus on the logic.
I can see the appeal. It turns AI engineer into something more like systems architect. You're orchestrating capabilities rather than just fighting with API keys. But let's play devil's advocate for a second. Is there a world where this unified layer is actually a bad idea? Where it becomes so heavy and enterprisey that it kills the speed of innovation?
There's always that risk. If the control plane becomes a bottleneck where every new tool or model has to go through a rigorous onboarding process managed by a central IT team, then yes, it could slow things down. The challenge for these tool makers is to keep it developer first. It needs to be as easy as adding a line to a Docker Compose file, even if it has all that enterprise power under the hood.
It's the Heroku versus AWS debate. You want the simplicity of a push to deploy, but the power of a global VPC. I think the winners in this space will be the ones who can abstract the complexity without hiding the control.
And that brings us back to Daniel's question about what to call it. I'm leaning towards AI control plane, but I also think we might just start calling it the AI stack. In 5 years, we won't say I'm using an LLM gateway and an MCP aggregator. We'll just say I'm deploying my app to our AI infrastructure. It will be as invisible and as essential as a database is today.
It's the industrialization of AI. We're moving from the artisanal, handcrafted prompt era to the mass production era. And you can't have mass production without a very solid factory floor.
Let's look at some second-order effects here. If we have these unified layers, what does it do to the model providers themselves? If I can swap between Gemini, Claude, and GPT with the flip of a switch in my control plane, does the brand of the model start to matter less?
It turns the models into a commodity. If the intelligence is handled by the control plane, the one that knows which model is best for which tool, then the models are just compute units. It's a race to the bottom on price and a race to the top on specific tool proficiency.
Which is exactly why OpenAI and Google are trying to build their own ecosystems. They want you to stay inside their world. But the market always pushes toward interoperability. No big company wants to be 100% dependent on a single vendor. The unified AI layer is the insurance policy against vendor lock-in.
It's also an efficiency play. If you have a unified view of your AI spend across the whole company, you can start doing things like spot instance routing for AI. Hey, Llama 3 is really cheap right now on this specific provider. Let's route all our non-critical summarization tasks there for the next hour.
We're already seeing that with OpenRouter to some extent, but imagine if that was tied to your internal priority levels. This request is from the CEO. Use the most expensive model and give it top priority. This request is from a free tier user. Use the local small language model. That's the kind of granular control that a unified layer provides.
So, for the folks listening who are currently neck deep in duct tape, what's the practical takeaway here? What should they actually do on Monday morning?
First, start mapping your dependencies. Even if you're not using a unified layer yet, you should have a clear inventory of every LLM and every tool, MCP or otherwise, that your agent is touching. You can't unify what you can't see.
That's a good point. It's like an AI audit. Who's using what and why?
Second, look into the open standards. If you're building tool servers, make them MCP compliant. If you're building observability, use open inference. By sticking to these standards now, you're making it much easier to drop in a unified control plane later. You're building plug-and-play components rather than custom hardwired ones.
And don't get distracted by the shiny new model every week. Focus on the plumbing. The model will change, but your need for security, cost tracking, and tool management isn't going anywhere. In fact, it's only going to get more intense as the models get more capable.
Finally, if you're in a larger organization, start evaluating those unified platforms we mentioned. Even if you just run a pilot with something like Graph-based Nexus or Tyke, you'll learn a lot about where your friction points are. You might find that your biggest problem isn't model quality, but tool latency or access control chaos.
I think that's the real aha moment for me today. We've been so focused on how smart is the AI that we've ignored how manageable is the AI system. The intelligence is the engine, but the control plane is the steering wheel, the brakes, and the dashboard. You wouldn't drive a supercar without those. So why are we building super agents with just an engine and a prayer?
It's a great analogy. Wait, I promised I wouldn't use analogies. But it's a good point. We're moving into the reliability phase of AI. The novelty is worn off, and now it has to actually work every time, at scale, without breaking the bank.
And if it doesn't work, we need to know exactly why it failed within seconds. The AI was hallucinating is no longer an acceptable answer for a production system. We need to say, the model attempted to call the Jira tool with an invalid schema, which was caught by our policy engine and flagged for the developer. That's the level of maturity we're aiming for.
One more thing to consider, the human in the loop. A unified control plane can also act as the approval layer. If an agent wants to perform a high-risk action, the gateway can pause the execution, send a notification to a human via Slack, and wait for a thumbs up before it allows the MCP call to proceed. It centralizes the human oversight, rather than having it scattered throughout your code.
That's a massive win for compliance. You can show an auditor a single log of every human approval that happened across your entire AI stack.
It really is a single pane of glass for the whole lifecycle, from the first prompt to the final action, and every check and balance in between.
Well, I think we've thoroughly explored Daniel's dream infrastructure. It turns out it's not a dream. It's actually being built as we speak. It has names like AI Control Plane and Single Origin AI Infrastructure, and it's the bridge between cool demo and mission-critical software.
It's a fascinating time to be in this space. We're watching the operating system of the AI era being written in real time.
I'm just glad I don't have to manually track every token myself. I've got enough trouble tracking where I left my favorite branch.
You're a sloth, Corn. You're probably sitting on it.
Touché. Well, this has been a deep one. I feel like my brain has been routed, namespaced, and observability checked.
And the cost? Minimal, hopefully.
Only a few thousand calories of thought. Thanks as always to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes.
And a big thanks to Modal for providing the GPU credits that power this show. They're a huge part of why we can dive this deep every week.
This has been my Weird Prompts. If you're finding all this infrastructure talk useful, or if you just like listening to a sloth and a donkey talk about control planes, leave us a review on your favorite podcast app. It really helps the algorithm find other nerds like us.
Find us at myweirdprompts.com for the full archive and all the technical deep dives we've done.
Until next time, keep your prompts weird and your infrastructure unified.
Goodbye.
See ya. This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts.